Warm welcome, and welcome into this talk about navigation component. I just have a few questions to ask you to start. Who already read a little bit of documentation or just seen a talk about navigation component? Raise your hand if you did it. Okay. Who is working with Nav Component as a daily basis? Okay, not so much. Cool. And all the other one, you never heard about Nav Component? Yes? Why are you here? No? No. Basically, this talk is made for you. I will try to have some basic introduction on Nav Component, but very quickly, just the thing I want to show you. So now we can go a little bit deeper about how to use Nav Component on different kind of project, and one precisely, but others at the end of the talk. And also, that's a good excuse, this talk, to understand a little bit of the internals of the library. So let's start. I'm Eyal. I'm working at Tiger. I joined them very recently to work on the future devices, future smartwatches, and the mobile ecosystem. And you will see that I left a company just a few weeks ago, and the most part of this talk is based on the job I've done during 1 year using Nav Component. You can just get the slide right now. Just follow this link, bit.ly/nav-component. There are some speaker notes with additional links and things like that. When there is source code, you have the link to the source code. Not the mine, but the source code from other people. And you will see that. Okay, let's start. Oh, I like that because with this slide, I see you all. That's cool. It will wake you up. Okay, let's start quickly because that's a long talk. Let's be short. I will first talk about the API, showing you the basics, okay? So the big picture is like this. When you are using Nav components, there are three main components, three main entities that you will deal with. The first is the nav graph. You have the nav host and the nav controller. So the nav graph is a graph that is declaring all the reachable destination of the navigation. Basically, all the screens that your user will be able to reach. And to write this nav graph, you do it in XML. In XML, there you also have an IDE with a WYSIWYG and things like that. It's pretty easy to use. You will see a lot of videos about that. I won't show it to you. We will focus on XML just to show you the API and the possibilities. There is also the nav controller. The nav controller is managing the app navigation within the nav host. And basically, the nav controller is your API to navigate using the nav component. So when you want to navigate, when you want to change the screen that is displayed, you will use the nav controller. And the nav host is basically the nav controller provider. It will provide you, the nav controller, but I'm sure that you won't have to implement it yourself. You will just use the API. You will see just very soon how. So now let's take a basic example. There is a recipe to do Nav component and to use Nav component. First, you need to add the library, because that's a library. Then you will create a Nav graph. When it's done, you will add an anchor into your UI. That's a fragment, basically, because by default, fragment is supported by Nav component. But you will see we can do other things than that fragment too. So you will add this fragment in your UI, and you will get the navigation controller. And then once you have the nav controller, you can navigate. And that's all. It's pretty simple. Here is how you can add the library to your project. Basically, this is the dependency to add. And if you are using Kotlin, and I really encourage you to use Kotlin right now, you can just add the dash KTX extension to this name. So you will have the same library, but with other extensions that are with a better API and a better DSL. About the navigation version, you see that this is a variable here. So the navigation version have to be 1.0.0 if you are using the support lib. But if you are using Android X, you have to use 2.0.0. That's exactly the same behavior, that's exactly the same source code almost, the same content in terms of library, but it will target different component, Android component from supportlib or AndroidX. And then you will build the nav graph. So for example, here is an example of nav graph. You have different screens. They are all called destinations. So when I'm telling the word destination here in this talk, it's not somewhere I want to go right now. It's just where the user could go. So destination is basically a screen. And you see that there are arrows linking these different destinations. Oh, sorry, one thing, yes. On your nav graph, you have to define the home destination, okay? But we will go a little bit deeper on the nav graph then. Also, you have different actions. You know that these arrows that are linking the destinations together. And actually, the destinations and the actions are doing the flow of your user. So here is an example of a nav graph. You see that's an XML that is pretty simple, even if it's XML, so it's really verbose. Yep, sorry. You have a navigation tab on top. Then you have different fragments that are declared. So 1 fragment, 2 fragment, and there is an action here. And on your UI, what you have is basically a container, the one you want, and you will just define fragments like you do already on your UI if you are using Fragment. Oops, sorry. And you have the name of the fragment that you have to add is the NavHostFragment. And actually, the NavHostFragment is the NavHost I was telling about. And this is really initiate and instantiate the Nav Component behavior into your application. And as you see, the NavHostFragment is actually a fragment. That's a headless fragment. That's a fragment without a UI. But with all the logic of navigating into your app using the Nav Component tools. Default NavHost is just a setting allowing the NavHostFragment to handle the back button on your project. And you will define, of course, the nav graph. And the nav graph is the XML resource I shown you right before. So you have a fragment with a NavHost, which is the logic of the Nav Component library. And there is your graph that will be bound to this NavHost fragment, just thanks to these 5 lines. And once it's done, inside your activity, you will call helper find nav controller. You will get this nav controller, and then you will just call navigate. Navigate with the destination, with the action you want to execute. So here in this example, the nav controller, I call navigate, and I give an action, fragment 1 to fragment 2. So I'm in the fragment 1, and I want to go to the fragment 2. But I can also just give a destination. In this case, I give the ID of the fragment I want to target, the ID from the nav graph. OK, let's dive in a little bit on the nav graph now. The nav graph, as I told you, it will declare all the reachable destinations, right? And there is this constraint is that you have to define one and only one start destination of your graph. It will also contain actions. You've seen that, right? Destinations is one node of this graph, is one screen. It's one screen to display, and by default, it's fragment, because on Nav Component, the default destination is a fragment. You have also actions, and these actions can be nested into the fragment. It will give the idea of, I want to go from this fragment to this targeted fragment, but you can also take actions and move it at the root of the graph, and it's called global actions. I won't go deeper into using the global actions just because I don't have time, but it's a pretty interesting tool to use sometimes. An action can contain a target destination. It must contain a target destination because, of course, it needs to go somewhere. You can also define animations into the actions. still, I don't have time to explain you the animation and how to use it, but it's pretty simple. And you can also define into this action the back behavior. So what's happening when the user clicks back? Do I have to go back to the previous screen? Or do I have to skip this screen and some others and go somewhere else in my graph? And something that is interesting with the actions is that that's something we don't use to on our Android layouts. All IDs in one layout must be different, right? If you have two same IDs, then your IDE and your bold is not working anymore. But on actions, they can share the same IDs. And you will see a little bit later on this talk that it can be very, very useful. Okay, a few additional features that you have in Nav Component. That's a list of features I won't talk about. But you need to know that it exists because they are very, very interesting. The first is SafeArgs. SafeArgs is a way to add arguments, to declare arguments on how to open a fragment, how to open a destination. So if a destination needs, I don't know, maybe a session ID or the ID of an item because you want to display the detail. If it needs it, you can put it on the SafeArgs. And you have a class that are compiled and give you a very interesting DSL to handle this bundle, basically. Also, Nav Component can be bound very, very easily to the navigation UI component. So the toolbar can be set. You can link the destinations to the menu, for example. The nav drawer, you know, the swiping menu that comes on the left of the screen, and also the bottom nav. Bottom nav, you have this component, it's called bottom navigation view with the tabs at the bottom. And you can bind your navigation directly to these components. It's handled. And I will tell a little bit problems that you can have with the bottom nav a little bit later. And deep links too. Deep links are supported in Nav Component. But again, I won't describe you these features. I just wanted you to know that they exist. So we can speak about more interesting things than just the documentation you can find on the web. Okay, now we have the basics, okay? I try to be pretty quick. I hope it's all okay for you. And we will see specific examples. I will take just 2 seconds to take a picture of you. Now I have a good light. Yes, so I want to tell a few specific cases. That problem are simple or hard problem that we had to solve, and actually, now I think it's more real use cases. It's not the thing that you can find on the documentation for most of them. But this is in the documentation. When you are navigating, sometimes you know you have the destination that is displayed, and you have decoration on top everywhere, and you want to change this decoration depending on the screen displayed. So there is a simple listener that you can have on your Nav controller. So like every listener that you have in Android, that's very standard. On Nav controller, add on destination change listener. And then, for example, here, when the destination changed, I update on my view model. You know, the view model is holding the UI content in this case. And I just compute the new title and inject it into my activity, okay? Depending on the screen displayed. But we did that, for example, on my previous project to update a progress bar on the long form that you want to your user to fill. So that's a very simple thing. Now, to go a little bit deeper, I want to tell you about the context of how I learned and what was the problem I had to solve and what was the context of the application I worked on before. I used to work at Conto, which is a banking service, mainly for companies. And the paradigm that have been chosen is that we had different activities, and each activity is actually an entry point for a feature. Okay, so there were many activities, but not one activity per feature. It was more one activity per screen. It was more one activity per feature. And it started in June. It started 1 year before we used Nav Component. We started used Nav Component in the project. And something that is really specific to this kind of banking application is that you have a lot of forms that your user have to fill to do actions. Because that's a bank, right? And if it's a bank for a company, it's getting worse. And for example, if you want to join a bank that is already, a bank account that is already existing, or if you want to create a bank account for your company, the flow that have been designed by the product team was composed by 66 screens, which is pretty big. And these have been designed a few months after the service have been created. So imagine in 1 or 2 or 3 years, what will be the content of this flow. But it was totally justified, to be honest, and it has been really well done, in my opinion. And the flow can be very complex. When you are registering a company, for example, you have to fill your information and the one of all the shareholders of the company. So you imagine that you have to fill a lot of things for different people, so you will have to do a loop into your graph in terms of navigation. So we had all these problematic. And we decided a few rules to be able to handle it cleanly and to make it maintainable in the future. So we decided to centralize all the logic in a single place for each feature, but it could be done also at the application level. Also, all the input and outputs of the activities are done on a view model because we decided to fit to the Google standards, let's say. And also, only one element will have access to the nav controller, and it's basically the single place I'm telling on the first item. These elements have access to the nav controller, and only this one. So what we created as a pattern is a flow manager. And basically, it could be called navigator. It could be called any name you want. We call that flow manager, but that was just our choice. And the idea is to convert navigation events to navigation destinations. And the role of this flow manager was also to look for the destination changes and be able to update the view model and to update the view state depending on the screen. So this is our role. And if we try to just see a little bit how it's implemented, but I will try to be short. So we have an activity that is composed by the view model, the flow manager, and the nav controller. And the view model will send events to the flow manager. The flow manager, as I told you, will transform these events into navigation actions using the nav controller to navigate. And on the other hand, nav controller will send event of a changing screen or anything to the flow manager, and the flow manager will update the view model. Okay? Is that clear for everybody? Yeah? Okay. And why we did that? Why we did that is because we really wanted to be able to test our whole flow. And the good thing is that when you decide this kind of pattern, you are able to test your flow because testing your navigation is basically testing the flow manager. So how did we do then to test that? We had to fake the nav controller. Then we had to send to, of course, instantiate the flow manager we want to test. Then send a navigation event to this flow manager and verify what the flow manager will give as an output. And basically, here is a very simplified source code, but I will just follow line by line. So here we are faking the nav controller. You don't care about the implementation right now. You just know that it's a fake nav controller. Then we will mark the lifecycle and the view model, just because that's something that is used by our flow manager. And what we are doing also is to mock a live data that is supposed to receive the answer from the flow manager. So we can check. Here we are instantiating our flow manager, injecting all the mocks and the fakes implementation. We are calling the action that is supposed then to give a result, and we are verifying the result here. So in this example, I want every time we switch screen, we have a button at the activity level that we want to be disabled. So when something happens, navigation event happen, I want to check that the button received the disable button state, okay? That's very simple. This is a very simple example, but it can be really trickier, and when you have very specific business rules, you can implement and check all of them into this kind of unit tests. On the 3 next slides, you have the implementations. Sorry, you have the implementations of the faking of the nav controller. How we did that. I don't want to go deeper. That you have the slides. If you want to just copy paste, it's really simple, to be honest. But I just wanted to make it as a reference if you want it. Anyways, and also how we mock the live data, etc. Okay, you will see in the slide if it's interesting for you. But I don't want to bore 90% of the room right now. Okay. So now we know that we are able to test and we have a methodology to test our flow. Let's see when our flow is getting a little bit wide and does very tricky things. Okay, let's start easy. Linear flows. Linear flows is when very simply, you have different screens and one screen go to another screen. So it looks like this. On your nav graph, you will have different fragments. In this example, we have 3 fragments. Each fragment, for the first 2 fragments have each one of an action. And each action is targeting the fragment that is after, right? Okay? And also, these actions have different IDs. So the first one is info to phone number. And the second one is phone number to verify SMS token, okay? That's just screens that we had to display. And if you just want the code to run that, in our flow manager, do you remember the flow manager will receive different kind of event and it will need to choose the good action to execute. So there is this method that is called navigate. And we will check the current destination. The current destination is the current screen that is displayed. It's not the destination I want to go, right? It's the current screen. So we check the current screen. And if we are in the info screen, we execute the info to phone number action. And if we're on phone number, of course, you get it. That's the other action that we execute. Cool. That's something we can do. But we can try to do something a little bit more efficient than that. If we change the both IDs to the same ID, the post-action IDs to the same ID, for example, action next, which is generic but which tells what it is for real, then the code that we have on our flow manager is really simplified this way. We navigate to the next action every time. Because we are linear, there is always one way to go. Cool. So that's how to solve, how to simplify, and simplifying things is really important in development. That's my wish, to have simple things to write. Yeah, so that's this rule that we decided to adopt in the team. So when a destination contains a single action, we will use always the same generic ID, and basically it was action underscore next. Now, if we have nonlinear flows, something like this. You see, here, the second fragment, the second screen, can have 2 targets. So how to handle this? So if we look at the fragment, the navigation graph, we have the first fragment here that have 2 actions. So we cannot use the same ID there, because then the fragment won't be able to know where action to really execute, because it doesn't have in one context you have 2 actions with the same ID, it's not working. So what did we do? Still very simple. We still check the current destination, and when it's phone number, we have this simple method that is supposed to compute or to decide where to go and which action to execute. And on all other cases, we always have the same action, because other cases are linear flows. And in the content of this method, it's really simple again. We will have, in this case, we use a view model. So we ask the view model, should the user verify the app token, or should we still directly go to the verify SMS token? And if the view model tells to go to the app token, we go to the app token. We go to the app token. Otherwise, I'm so sorry, you go to the SMS token. And then you have the logic to go to the two good directions. Okay, now, if our graph is getting a little bit more complicated like this, or even like this, or even like this, and this is the flow I was telling about at the beginning. You have 66 screens right here, and what you see here notably is a circular flow. For real, you will have to deal with this kind of very wheel flow, and actually the flow is like this, you see? Okay, let's see how to simplify that, because of course there is a logic, there is something complicated that we have to implement. But let's try to make it simple to understand and simple to maintain. So what we had to do, and what we decided to do in this case, is that behind our flow manager, we will have something that we called a flow, but again, you can call it the name you want. I don't really care. But that's a flow that will be defined there. That will receive the current destination, and then an object containing the current state of the navigation. In our case, it was formulas, because basically our user was filling a form, and this form was able to give us what's to implement all the business rules to tell what's the next action to do. But you can pass also the view model. In some features, we just passed the view model because we needed the view model. In return, the flow will give the next destination ID, and actually it will give the next action to execute, the next action ID. So the flow, it's a map that is containing the navigation logic. And in input, you have a key, and the key is a current destination. And as a feedback, as an answer, you have the logic to determine what's the next action ID to execute, to navigate to. Just now to show you real code and how it's implemented, you will see it's pretty simple. We have an object. You can do on any ways you want. We decided to use an object, which is called, in this case, register flow. Then this register flow defines a data class inside that will define an action. So that will be the map value type, you know, that the return type. And as an input of this action, you have a lambda that is taking as an argument the POJO I was telling about right before, or the view model, or the current state of the navigation of the user, the current data that allows you to decide and to implement the business rules. And as an answer, there is an int, and that's the int of the action that we want to navigate to. So now here is the map. The map is a simple map with the key of the ID of the current screen, and then we map it to an action that we create this way, with the lambda as an argument, a constructor argument. And inside this lambda, we will implement the logic. So in this action, when we are on the phone number, we check that the user have or not invitations. So if the user have invitations, we redirect this user to the invitation selection screen. Otherwise, the user wants to create a new bank account, and he will go directly to the pricing screen. So you see this kind of rule that can be tricky to handle. Now we have one single place where all our business logic, all our navigation logic is stored and is clear to be maintained. And of course, the register flow have an API because we don't expose the map directly. We have this simple method that is giving as a parameter the destination ID and the form, you know, the one giving the navigation state. And then for the current destination ID, we try to, if it exists, to execute the next action. And this will return the action to execute, the action ID to navigate to. And otherwise, like we did on the first chapter of this section, we return the default action, action next. And this way, we add something very simple and very easy to understand and to maintain. If we want to complexify the flow, it's easy. And to be honest, this has been done twice since I left the company. And it was almost a pleasure, which is crazy when you are thinking about these kind of problems. Okay, so that's how we try to simplify the way we implement this weird logic that we have to implement. Something that we need to handle. Sometimes you have different start points to handle. In this example, here is 3 login screens. So there is the login, or do you have the reconnect? You know that's the one that is displayed when the user already logged in, and the forgotten password. And these 2 destinations can be actually the start destination of your nav graph, because of course, if the user already reconnects, you don't want to display the login screen. You want to display the reconnect directly. But you have to choose. So we choose to put the login as the default screen. And what you want is very quickly, once the activity is started, redirect to the reconnect screen. And this is the nav graph, for example. And you want to do this action very quickly. And that's pretty simple. The way we did that on the onCreate, we will instantiate our flow manager, of course, and we will call on the flow manager a simple method, navigate to initial destination. Then inside this method, we are checking at the view model, in this case, but you can do that on any way you want. Is the user ready for reconnect, or is it okay? We don't need to redirect it. And if we need to redirect it, we do it very simply with a navigate, with the action to execute. To make it short, actually, it was not possible because of specific animations, transitions between the screens that the design team asked us to implement. The team decided to put what has been wrongly called a splash screen to be able then to redirect directly to the login or to the reconnect. And actually, what is the splash screen is a very simple fragment that has no UI. That's just a fragment. Also something that with the both actions that are directing to the login or to the reconnect, we say that the user should pop up to the splash with what is called a pop-up inclusive. It means that when the reconnect, for example, will pop, it will include the screen before, so the splash will be dismissed too, and the app will quit. And this is the implementation of the navigation logic. You know, that's exactly the same method I've shown you before. But what I want to tell you is that this is not working. This is crashing. This is crashing when the user rotates the phone or changes the language and comes back to your app. And I will show you why, because this is an excuse to understand a little bit how the Nav component is what the Nav component is doing from inside. So when your activity is created, then the NavHostFragment is created when you add it into your UI. Then the Nav controller is automatically created for you. Okay, so this is pretty simple. And when you start navigate, the Nav controller will hold what is called destination backstack with the first destination, the home, the start destination. Here it's splash. Then, do you remember, we automatically redirect to the login destination. Okay, that's cool. Yeah, and the current destination at this moment is login, right? Okay, so now if the user rotates the phone, the activity, the NavHostFragment, and the Nav controller will be called on the save state method, the respective save state methods. And then, what the Nav controller is doing, it will save the backstack before it gets destroyed. Then the activity is respawned, and the Nav controller will get back this backstack. And at this moment, the current destination is still login. And it's not the splash as we did before. So when we are calling navigate to initial destination, if we call an action where that is linking two destinations, but you are not on the first destination, the app crashes, and that's normal. So what we did is that we checked the current destination and checked if it's the start destination of our nav graph, then we can redirect. If it's not, we don't have to redirect because we consider that's a restoring state. Many of you will think, yeah, but there is a possibility to check that at the activity level, you know, because you received a safe state bundle and check if it's null. Yes, but actually we decided to have a robust flow manager, and we wanted to test this case too. And if you do it in the activity, you cannot test this case. So that's the reason why we did that. Yes. How many times do I have still? Yeah? 20, is that? 15? 15, okay. 15 minutes. I need to be short. If you don't use fragments in your app, you can do that. I will be short because I don't want to give you all these implementations. But basically, what you need to know is that if we consider, you know, that's the previous graph that we have, but the nav controller is connected to what's called a navigator provider. And this provider is actually a hash map linking the name of a tag from your nav graph to what is called a navigator. And the navigator is a logic. It's a simple class implementing the logic of navigation. You see, for example, on your navigation, you can have fragments, like we did so far on the talk, but you can also have activities. And by default, when you are using the navigation fragment library, you will have the navigator, the fragment navigator. And what the navigator does is that it defines mechanism to navigating within the app. For example, for fragments, it will use this fragment manager to switch the different fragments, to add the shared elements, etc., and to do the transitions, you know, transitions between screens. It does that all for you. It will, of course, manage the backstack. And when you are defining your navigator, because you can implement your own navigator if you want, you need to put as a header the navigator.name annotation. This way, for example, if we take the fragment navigator, the current implementation, you have this fragment annotation. Again, I won't go deeper because, as you see, I don't have time. But there are still many things to come. Yes, but to be honest, I did that for navigating. We had a custom bottom bar on the Conto application. And you'll see right later, we'll talk about the bottom navigation and the problem that we can have. So to solve this problem, we decided to implement our own navigator. And what we did is that I created a fragment tab navigator. And in the annotation, it was called fragment_tab. And we had this own navigation graph that we designed with these tags. Yes. OK, so if you want to go deeper, you have some people are doing, for example, an ex-colleague from Genymotion is doing navigation between dialogues, for example. This can be very useful. You can find many snippets of navigator to implement yourself. OK, let's tell about bottom navigation. And what I want to show you right here is this. Here is a simple video. When you are using the default implementation of the when you are using the default implementation, the default binding between Nav Component and the bottom navigation view, you know, the default attribute. When you are navigating from one item to another, you see that I'm on the second tab, then I scroll, then I go back to the first tab, and I come back to the list. You see that I came back on the first item. So the scroll has not been kept. It has not been stored. I lost my state. I do that. So I am on item 4. I come back. And then I'm on item 1. And this is a problem for many applications. Because, you know, there is a big debate about what we are allowed to do or not. But most of application needs to keep the states. And I can give you very correct argument for that. Cool. What's happening? When you are, so that's from the documentation. When you want to bind your view to the nav controller, you have to call this method set-up with nav controller. And this method is linking is listening actually the bottom navigation view, and it's called this method on nav destination selected when you click on a button. And what you see here is the options that are given. So basically, when you are clicking on a new tab, it tells that the tab have a pop-up to the home fragment. And the first fragment is actually the first tab of the navigation view. So if we take an example and try to figure out what's happening for real, we have these 3 tabs: home tab, tab 2, and 3. They are both linked to the home tab fragment in terms of pop-up 2. So when the user opens the app, we open the home tab fragment. Then we want to add the tab 2. Okay, it's added. And when we want to add the tab 3, then we notice that actually tab 2 should not be on the backstack anymore. And it's dismissed directly from the backstack. Okay, and if I click back on the tab 2, actually the tab 3 will be dismissed. But the problem here is mainly that the tab 2 instance is a new one. It's not the previous one that had been detached and then reattached like we used to do. And this is a problem. And this has been a problem that has been raised on the bugs. So there is a bug on the bug tracker of the Nav component. And Eyal Lezmy, which is the main developer of the library, answered to tell you, don't read that, really. It tells in this, in short, that basically, yeah, that's something that we want to tackle. Right now, there is a limitation because to support that, we need to support different backstack at the same time. And this is not supported on the on the current version of the Fragment Manager. But we will come later with a hack to do that. And then a few months later, they come back to that, to giving this hack. So just I will try to explain you what is the hack. That is pretty interesting. So you have your activity, you have your nav graph with the 3 tabs. And for the example, I added another fragment behind the tab 3, the detail, for example. And you have your NavHost, and this NavHost is linked to the nav graph, right? And you will have the tab host, fragment, the tab 1, sorry, that will be displayed. Then the tab 3 with the tab 1 behind. Then, for example, the detail. So you will have this backstack that you can create. But if you come back to tab 2, you will lose the detail and the tab 3. Okay, so the hack is actually to use several NavHost fragments to create several backstacks. If we take, again, this schema, on our activity, we will have a frame layout that will be the anchor of our tab navigation. We will split the nav graph. So you will have, for each tab, you will have a separate navigation graph file. And each tab will be bound to a specific instance of NavHostFragment. And then the frame layout will attach or detach the NavHostFragment you want to display. And this way, you have different backstacks. That's a hack, but it's working correctly. And we do that, for example, on my new project at Taghoyer. We do that with a few modifications. And what you do, basically, to do that, is that you create this list of navigation files, navigation graphs. Then you will set up again the bottom nav view with a specific implementation that is an extension method, Kotlin extension method, but you can do that in Java too, giving all the logic to do what I describe you. And it's open source, so you can just copy-paste it in your project and maintain it the way you want, okay? Okay, one last technical topic, and then I have a conclusion. Multi-module navigation. That's something I discovered pretty recently because for a very specific reason on our previous project, we decided to have one module, but at Taghoyer we have multiple modules. And there is a problem, I mean, yeah, there is things to handle, to handle correctly the navigation when you have multi-module. So most of projects have an app module with different other modules that are bound most of the time to features. And these features basically have another module that is called base in this example, but it could be, I don't know, Android common. Yeah, for example, us, it's base UI, okay? Anyways. The features will contain the fragments of the screen to be displayed. And There are many ways to solve. There is an interesting, on the speaker note I added the link, an interesting article by David Vavra about how they use navigation component. And he tells about the multi-navigation module. And there is a way to solve that. It's you have the nav graph and at a single place on the base on the base module. But the problem is that you can create that, but in the base module, if you have your nav graph, all the fragments that you declare on your feature, you won't be able to see it. And it will be red, you won't have auto-completion, and also you won't have any preview displayed. Okay, so yeah, the classes are not fun, right? So a solution to solve that is to put the nav graph into the app, right? Because the app depends on the different features, and it has access to the fragment, to the layout, and everything. And then, yeah, it's all green, right? But there is a problem with that, is that if you do your logic from the features, for example, you won't be able to link it all together. Also, something that is, because you won't have the nav graph IDs into your different model. Another thing is that it will break SafeArgs. That is a pretty interesting feature. It generates class, but it won't generate in the feature. It will generate the class on the app module. And it's a problem. So the perfect world will be to have the nav graph in the both app module and the base module. How to do that? And we scratched a little bit our head, and we had an idea just to look at the SafeArgs Gradle plugin source code. And what we found was really interesting. So to generate the SafeArgs classes, the plugin is looking at the variant source set, checking for the navigation folder. And we were saying, oh, they are checking the source set, but the source set, we can configure it. So what we did is actually we created a specific folder that is intended to be shared among the different modules, containing only the navigation in our case. And this folder will be shared among others, among the app and the base modules. And you can do that very simply on each app and base build.gradle. You just add these paths, the share res for a path to the source set. One thing to note is that on the app, we add the source set only on debug, because if you add two nav graph, it will generate the both same class on the both modules, and ProGuard will fail. So on release, we are prograding. We are not prograding on debug. So we decided to do that only for debug. And basically, that's a two-line fix for us using official APIs, and it solves all the things. I will conclude. But actually, it's a hack. I won't go into too much detail, but the fact that the context of the nav graph is given to the app is a hack. Single activity, what I want to do is very short. Do whatever you want. Nav Component is ready for multiple activity and single activity. It's really made for that, and it's really well made for that. And as a conclusion, I want to tell you that Nav Component is clean and future-proof. I experimented since last July. It's a Google standard, and I really like the idea of Google providing on development standards on an Android. It's very easy to add it to a project, I can tell you. And the tooling is crazy. I've not been able to show you the tooling, but right now, if you have very complex flow and you are able to show that to the product team, they are extremely happy to understand how complex the thing they want you to develop is. And of course, it's not perfect, but I really encourage you to test it if you can. Thank you.